Standard 12th, Subject Physics, 8th chapter, Electrostatics. From this chapter, let us see what is electric potential and potential energy. Electric potential is defined as the amount of work needed to move a unit positive charge from a reference point against an electric field. Electrostatic potential energy is the work done against the electrostatic forces to achieve a certain configuration of charges in a given system. As every system tries to attain the minimum potential energy, the work is always done to change the configuration. Now we know that the like charges repel and the unlike charges attract each other. A charge exerts a force on any other charge close to it. Therefore, some work is done to move a charge in the presence of other charges. Thus, the potential energy arises due to the collection of the charges. Now, the work done will be explained. For that purpose, let us consider a positive charge Q kept at some point in the space. For bringing any other charge, that is positive charge, close to it, work is necessary. This work done is equal to the change in potential energy of that system, and thus work done against the electrostatic force. The work done against the electrostatic force is equal to increase in potential energy of the system. Work done against the electrostatic force equal to increase in potential energy of the system. Now when the charge is displaced through distance dr due to the force F, then the increase in potential energy du is given as the product of F and dr, that is du equal to factor F dot factor dr. So this is regarding the electric potential and the potential energy of the electric charges. Now let us see the next point, that is the units of potential energy. What are the different units of potential energy? That is electrostatic potential energy. So the SI unit of potential energy is joule. SI unit of potential energy is joule and can be defined as 1 joule of energy is the energy stored. 1 joule of energy is the energy stored in moving a charge of 1 coulomb through a potential difference of 1 volt. 1 joule is the energy stored in moving a charge of 1 coulomb through a potential difference of 1 volt. Now another unit of the potential energy is electron volt EV. Now that electron volt EV is given as 1 electron volt equal to 1.6 into 10 raised to minus 19 joule. So that is the relation between electron volt and joule. Now this unit can be defined as, that is the unit of potential energy, electron volt. It is electron volt, which is the change in kinetic energy of an electron while crossing 2 points maintained at the potential difference of 1 volt. So electron volt is the energy, or it is the change in kinetic energy. It is the change in kinetic energy of the electron while crossing 2 points maintained at the potential difference of 1 volt. Now some other units are also used for the measurement of this electrostatic potential energy, and these units are 1 milli electron volt, that is equal to 1.6 into 10 raised to minus 22 joule. Similarly, 1 kilovolt equal to 1.6 into 10 raised to minus 16 joule. So these are the different units used for the measurement of this potential energy. Now let us see in short the concept of potential. The potential energy of the two particle system at a distance r, that means if the two charges or two particles are separated by a distance r, then its potential energy ur is given by the formula ur equal to 1 upon 4 pi epsilon 0 q1 q2 upon r. It can be also written as q1 upon 4 pi epsilon 0 into q2 or q2 upon 4 pi epsilon 0 r into q1. So by separating q1 and q2, this energy is written. Now in this case, the quantity q upon 4 pi epsilon 0 r, whether that q is q1 or q2, but it is simply taken as q, and therefore the quantity q upon 4 pi epsilon 0 r is called as electrostatic potential, denoted by phi r. That is the electrostatic potential, and therefore from this relation we can say that this electrostatic potential energy electrostatic potential energy ur is equal to electric potential phi into the charge q. So electrostatic potential energy is equal to the product of electric potential phi and the charge q, or from this relation this electric potential will be the electrostatic potential energy ur per unit charge q. The charge will get divided here to this electrostatic potential energy, and that will be the electric potential. And therefore, if we consider the electrostatic potential difference between any two points in the electric field will be given as the electrostatic potential difference between any two points in an electric field will be given as, it is given as phi2 minus phi1, v2 minus phi1. Phi1 and v2 will be the potentials of two different points, that will be equal to u2 minus u1 upon q, that is change in energy per unit charge. So that will be equal to change in energy is nothing but work done, so that it is dw upon q. So this will be regarding the concept of electric potential. And now let us see the relation between electric field and the electric potential. How the electric field and electric potential, both these terms are related, that we will have to study. That is the relation between electric field and electric potential. So in order to obtain the electric field, relation between electric field and electric potential, let us consider a charge plus q. So there is a plus q charge which is placed at point O. So this charge will be considered as the source charge, and therefore consider plus q charge placed at point O, which produces electric field around it. Now the electric field produced due to this plus q charge will be directed away from the charge. So this E represents the direction of electric field which is produced around that charge plus q. Now it is always directed away from that charge q, and therefore now let us consider a unit positive charge plus q0 which is initially placed at point M. So this is the unit positive charge. So let that unit positive charge q0 is moved from point M to point N through a small distance dx. It will be displaced against the direction of electric field. Then the force due to electric field is acting on that charge which is directed along OM, that is in the direction of electric field, and therefore the work done is given as work done is equal to force into displacement. Therefore it is dW is equal to minus F into dx. This negative sign indicates that force and displacement are oppositely directed, because force is acting towards M and this displacement is from M to N. As they are oppositely directed, therefore there will be negative sign. So dW, that is equal to minus F dx, it is also written as equal to minus E dx, where E is the electric field. Now dW, that is the work done. So how it will be then written? So this work done on unit positive charge is equal to the potential difference. The work done will be nothing but it is the potential difference between the 2 points M and N, and therefore this work done dW on unit positive charge is equal to potential difference between M and N, and hence we can write dW equal to dV, that is change in potential or potential difference, that is equal to minus E dx. So dW, this work done, will be equal to potential difference, that is equal to minus E dx, and therefore we can write E equal to the electric field E is equal to minus dV by dx, where this term dV by dx is called as potential gradient. It is the potential gradient, and hence this equation will represent the relation between electric field and electric potential. So electric field E equal to negative potential gradient, that is minus dV by dx. Now let us see the term which is called as zero potential. What is that? Zero potential. So the potential at any point in an electric field is the amount of work done to bring a unit positive charge from infinity to that point. Once the 0 point of the potential is set, then every potential will be measured with respect to that reference potential. Every potential will be measured with that reference potential, and the zero potential is set conveniently. The zero potential will be set conveniently. So zero potential is nothing but it is only the reference potential with respect to which all other potentials will be measured.